All right, in this video, we want to derive this rational function over here. And at first glance, it might look like there's a quotient rule on the inside, but technically there's no x in the numerator. So the first thing we want to do is we want to simplify this question by simply moving this bracket to the exponent and to the top and making the exponent negative. Now we want to derive this function over here. This is going to be a double chain rule. So let's start with our derivation. The first thing you want to derive is the outside always, which is this exponent to the 4. I'm going to bring this 4 down. I'm going to write the exact same thing inside the bracket. And then I'm going to subtract 1 from my exponent. So I'm going to make my exponent 3. Then I want to multiply by the derivation of the inside of the bracket according to chain rule. Basically pretend like this whole thing here doesn't exist and we're deriving the inside. We want to multiply by that over here. So if I derive the inside, I'm going to start by doing -2 times -2, which is +4. I'm going to write the exact same thing inside this bracket. And I'm going to subtract 1 from my exponent. So my new exponent is going to become -3. And then finally, my double chain rule means I got to multiply by the derivation of the inside of this bracket. Basically, you pretend like none of this exists and all we have here is this bracket. So if I derive the inside of this bracket here, the derivation of 3x, oops, I forgot to write my square here. The derivation of 3x is just 3, and the derivation of x squared is just 2x. And this is my final derived solution, although I can simplify it. I can't multiply this number with this number because this number has an exponent, so I can't really touch that. I'm going to multiply this number with this one because this number has no exponent outside the bracket. The exponent is only for this term over here. So 4 times 4 will be 16. Then inside the bracket here, just going to write this as -2 divided by 3x plus x square and make this exponent a +2 because we don't want negative exponents in our final solution. Then this whole thing is cubed. And then this 4 I already multiplied with that 4 to give me the 16. So this is just going to turn into 1 over 3x plus x square cubed. And then this is just going to stay the same 3 plus 2x. Now this can be simplified a bit further. I can distribute this cube into this bracket, and it's a bit important to do that. We're going to have 16. -2 cubed is -8. And then over here, I have to just multiply these two exponents. So that's 3x plus x squared to the power of 6. And these two brackets don't change at all. And then last step, I can simplify again, is 16 times -8 is going to be -128. Times 1 means it's just the same thing, and then times this. So 3 plus 2x in the top. And in the bottom, I can combine these two here because they're exactly the same. When I multiply them, I'm just adding my exponents. So my new exponent is 6 plus 3, which is 9. And this is my fully simplified solution to this first question over here. Let's take a look at the second question. This one is one function divided by another function. So I need to do my quotient rule, which is f prime g minus g prime f divided by g squared. F is always the top, but I'll rewrite it simplified. I'll get rid of the square root and write it as an exponent of 1 over 2 because that's going to be easier to derive. G is just the denominator, which is x cubed plus 2x to the power of 3. And then f prime is 1 over 2 times 2 is just 1, so I don't need to write that. If I subtract 1 from my exponent, I'll get negative half. And then I have to multiply by the derivation of the inside of the bracket, which is just 4. So for now, I won't simplify this in a too complicated way. I'll just write it as 4x minus 1 to the half. Oops, negative half. And g prime, I'm just going to bring the exponent down, 3x cubed plus 2x. My new exponent is just going to be 2. I'm going to multiply by the derivation of the inside of the bracket because of my chain rule. So that's just 3x squared plus 2. Now I'm going to sub all of this into my quotient rule over here. So f prime times g minus g prime times f divided by g squared. That's 4 times 4x minus 1 to the negative half times x cubed plus 2x to the power of 3. That's f prime g minus g prime times f. I'll do 3 times 2 first, which is 6. Then I have x cubed plus 2x squared, 3x plus 2, and 4x minus 1 to the power of half. And all of this is divided by g squared, which is x cubed plus 2x cubed squared. Now this one can also be simplified. There's actually 2 different ways to simplify when you have fractional exponents. You can either common factor, and if you know how to common factor with fractions, that's the quicker method. Or you can make a denominator and then make a common denominator on the top and then factor. I'm just going to common factor out over here for the negative exponent that has a fraction because that's how the student I'm teaching is doing this question. And by the way, this is just w prime x, this question. So my largest common factor in the numerator between the two numbers, it's 2. Between these, I'm going to common factor out 4x minus 1 to the negative half. And between these two, I can common factor out x cubed plus 2x squared. So now if I common factor this out, let's see what I'm left with. The 4 divided by 2 turns into a 2. 4x minus half divided by 4x minus half is just 1, so I don't need that anymore. And if I take out 2 of the 3 of these, I'm just left with x cubed plus 2x here. 6 divided by 2 is 3. This whole thing is just going to disappear because I've already taken them all out. And 3x plus 2 will remain. And over here, if I common factor out 4x minus 1 to the negative half, 4x minus 1 to the positive half divided by 4x minus 1 to the negative half means I'm just subtracting the exponents. Half minus negative half is just 1. So I'm just left with 4x minus 1, the exponent of 1, which I don't have to write down anymore. So that common factor step is quite difficult. If you didn't understand, I would suggest practicing common factoring with fractional and negative exponents to kind of get better at that. The denominator can just simplify. 3 times 2 is just 6. Now I can cancel this and I can turn this into a 4. I can multiply this 2 into this bracket and I can also FOIL out these 2 brackets over here. And I can also move this to the denominator in this question because it has a negative exponent. Let's do all of that in the same step. I know it's a lot. 4x minus 1 to the half, x cubed plus 2x to the 4. And in this bracket, I have 2x cubed plus 4x minus 3. And then if I FOIL out these two brackets, I'll get 12x squared. It's going to be minus 3x plus 8x, which is plus 5x minus 2. Then I just need to expand out this bracket by multiplying this negative 3 in here. So 2x cubed plus 4x minus 36x squared plus, minus 15x plus 6. Denominator doesn't change, although you could rewrite this with a square root. Your teacher expects you to do that. If not, you could just leave it as an exponent and there's no issue with that. And I'll just combine like terms inside the bracket. And it's 2x cubed minus 36x squared minus 11x plus 6 divided by square root of 4x minus 1 times x cubed plus 2x to the power of 4. And that's my final solution to this question over here. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button and help me get to 1,000 subscribers. This is video number 539 without making a single dollar. So I would really, really appreciate if you did that for me. Thank you for watching.